Look up on a clear night. You will see a familiar friend. The moon hangs there, a silent, glowing sphere in the velvet darkness of space. Its calm presence shapes our myths, our calendars, even our biology. It pulls on the great oceans, creating the rhythmic breath of the tides, a beacon that has watched over Earth for billions of years. But what if it were not so permanent? Imagine that silent, familiar face begins to shift. The silvery white glow might become a fiery orange, or a cracked, icy blue. It could shrink to a pinpoint, or swell to dominate the entire night sky. What would happen if our moon were replaced by another? The moon's most famous role is as the master of the tides. Its gravity tugs unevenly, raising twin bulges in the oceans that sweep around the world as Earth spins. Those tides mix waters, distribute heat and nutrients, and cradle coastal ecosystems where life flourished. The moon also steadies Earth's axial tilt, about 23.5 degrees, giving us stable, predictable seasons. Without it, our tilt could lurch between mild and extreme, wreaking havoc on climate. Over eons, tidal friction has slowed Earth's spin, stretching a frantic 6-hour day into the 24 hours life now knows. Creating tides, stabilizing our axial tilt, and lengthening our day. 3 functions that made Earth remarkably stable. That stability enabled the slow unfolding of evolution. The moon is not passive, it's a partner in the dance of life. Let us begin with Phobos, Mars's lumpy potato-shaped moon, only about 22 kilometers across. Placed at our moon's distance, it would be almost invisible, just a wandering star. The romance and guidance of moonlight would vanish. Its gravity is negligible. Ocean tides would shrink to centimeters. Tidal mixing would cease, fostering stagnant zones and disrupting marine life and climate patterns. Worse, without our moon's anchor, Earth's tilt could wander, flipping climates over millennia into long, punishing extremes. The slowing of Earth's rotation would halt, even reverse slightly, disturbing our 24-hour rhythm and intensifying winds and storms. Next, Europa. Smaller than our moon by about 10%, etched with reddish cracks across bright ice. In our sky, it would gleam, slightly smaller yet dazzling. Being less massive, its tides would be smaller, perhaps 2/3 of today's, reshaping coasts and marine life cycles. But Europa lacks the mass to lock our tilt, inviting long-term climatic swings. Earth's tides could flex Europa violently, driving cryovolcanism and ejecting water ice into space. Captured particles might moisten our upper atmosphere, nudging energy balance and chemistry in unpredictable ways. A smaller, icy moon would be cold comfort for a planet losing its climatic poise. Now Titan, Saturn's largest moon, veiled in a thick nitrogen haze. Nights would glow dim and orange, a dusky twilight instead of silver light. Larger and more massive than our moon, Titan's pull would be far stronger. Tides would become monstrous, surging bores scouring coastlines and cities twice a day. Enormous tidal energy would heat waters and power hyperstorms of staggering ferocity. Tidal breaking would accelerate, stretching days to hundreds of hours, weeks of scorching light, then deep freeze. So close to the sun, Titan's haze would erode, releasing methane and hydrocarbons that could trigger toxic smogs and dim the sun. The arrival of Titan would be apocalyptic for life at the surface. Finally, Ganymede, the largest moon in the solar system, even bigger than Mercury. It's the only moon with a magnetic field, a world of rock and ice, cratered and grooved. Its bright, vast disk would banish darkness into a perpetual silver dawn. With more than twice our moon's mass, Ganymede would drive daily supertides that obliterate coasts and redraw continents. Its gravity would flex Earth's crust, igniting quakes and volcanism in a new era of geological fury. Days would lengthen even faster than with Titan, bringing intolerable heat by day and lethal cold by night. Yes, such mass could stabilize our tilt, but everything else would make that point moot. the king of moons would spell the end of the world as we know it. Beyond tides and geology, orbital mechanics complicate any swap. Our moon is tidally locked, one rotation per orbit, always showing the same face. A new moon would likely arrive tumbling, revealing ever-changing faces in the sky. Night itself would change. Dim orange haze under Titan, near-dawn brightness under icy moons. Brighter nights would scramble navigation, hunting, and mating, unraveling ancient ecological rhythms. Capture is perilous, too fast or misangled and it could miss us, or collide catastrophically. Too close and Earth would tear it apart, forming rings and unleashing deadly meteor showers. Studying our moon's role guides the search for life. Habitability may depend on the right kind of moon. Swapping our moon is a powerful exercise in perspective. Each scenario shows how size, mass, and distance are finely tuned for stability. For billions of years, that balance let life evolve in all its complexity. On worlds with no real tides, life might remain confined. Under giant tides, it might flee underground or take to the air. Our moon steadied seasons, mixed oceans, slowed our spin, and lit our nights, helping make Earth a garden. If one moon can shape the fate of an entire planet, how rare is our perfect balance?